Learning Objective 1.1a wants you to graph numbers on a number line. Here we have 7 different numbers they want us to graph on this number line. Notice all these numbers are in different formats. What I would do is get them all as a decimal and then compare them. So this was already a decimal, so let's change this fraction to a decimal and this fraction to a decimal and then compare them. To do 11/4 on your calculator, just type 11 divided by 4. And you're going to get that this is 2.75. And then for 5/3, do 5 divided by 3, and you're going to get 1.67. Now we need to put them on the number line, so let's look at the largest and the smallest numbers that we have. It looks like the largest one is the 4, and the smallest is -5. So let's do the tick marks accordingly. If we do this as -5, and we'll work our way up to -4, 3, -2, -1, and 0, then 1, 2, 3, 4, and 5. Now let's put these on the number line. -1.6 is going to be between -1 and -2, but closer to -2. So let's put that right about here, and let's label it as -1.6. 11/4 is the number 2.75, which is in between 2 and 3, but closer to 3. And let's actually write 11/4 so for that one. So let's put it right about here and label it 11/4 in its original format. -0.5 is going to be between 0 and -1 and right in the middle. So we'll just label that and do a -0.5. Next one is 0.8. That's between 0 and 1 but closer to 1. So we'll label it right there at 0.8. Then we're going to have 5/3, which was 1.67. It's in between 1 and 2. It's going to be closer to 2, so we'll do that. And we're going to again label this one. This was the number 5/3. And then the last two, let's put -5 and 4 both on there. So -5 is right here, and we're going to label it. And then 4 is right here, and label it. Now, Learning Objective 1.1b wants us to list the numbers in increasing or decreasing order. Let's actually put these numbers in increasing order. So increasing means from smallest to largest. Now we've already put them on the number line, which is nice, so we can actually see their increasing order from smallest to largest right now. So if we just take that, we can see it's -5, then the -1.6, and so forth. So if we write those, again, this is increasing order. It's -5, -1.6, -0.5, 0.8, 5/3, 11/4, and then the number 4. 1.1c and 1.3a are similar. Translate the verbal model to algebraic model and simplify, or write an algebraic model and evaluate. So here's a scenario. A restaurant charges $9.95 for a large pizza with 2 toppings, and $1.25 for each additional topping. Write an algebraic model for the total cost of a pizza with T number of toppings. So to set that up, they first want us to find the total cost of C. So we'll say that C equals. And we want to have for T number of toppings on the pizza. So the cost of the pizza is going to be made up of 2 things. First is $9.95 for the initial cost. And that one actually comes with 2 toppings on it. And then for every topping above 2 toppings, it's $1.25. So let's add to that $1.25. Now you want to be careful and think about what to put here for how many toppings. If we put T toppings, and you think about this equation, if you have 1 topping on your pizza, if you put 1 in here, it's going to charge you $9.95 plus an additional $1.25 for 1 topping pizza. But that's not correct. The key here, the first 2 toppings are included in this price. So what you have to make sure you do is take the number of toppings minus 2. This is going to be the right equation. The reason I know is if I put in here for 2 right now, if I ordered a 2 topping pizza, 2 minus 2 is 0, and this cost here won't be added on. It'll tell me it's $9.95, which is correct. So the last part of this equation actually wants us to find the total cost of a 3 topping pizza. So if we use our equation, it's going to be $9.95 plus $1.25. And if you do 3 minus the 2 in our equation, what it's going to do is just charge us for 1 extra topping. So So it's the $9.95 plus $1.25 times 1. So 1 extra topping for that. And then the total pizza price is going to end up being $11.20. Objective 1.2a wants us to evaluate powers. And let's actually do this one here first. What this says, this is the base and that's the exponent. So this is the base of -3, has to happen 4 times. So what they want us to do is to repeat that -3 4 times. And this is in multiplication. So if you multiply this all together, what you're going to notice is the answer is going to be 81. If you want to break it down yourself, a -3 and -3 is a +9. This -3 and -3 is a +9. So now you have 9 times 9 is the 81. Now you have to be careful when you go back to this one. This says -4 squared. What are you actually squaring? In this case, we're just squaring the 4. That little negative is sitting out there all by itself. So I'm going to write the little negative sitting out there, and then what I'm going to do is repeat the 4 2 times. Notice the negative is still there, and 4 times 4 is 16. The answer here is -16. What you want to take away from these two examples is, where is the negative? Do you repeat it here like we did, or does it stay on the outside? If the negative is within the parentheses, you actually repeat it like that. 1.2b, use the order of operations to simplify. Don't forget your order of operations, PEMDAS. Remember what that means is first you do parentheses, then exponents. And then when multiplication or division are together, you go left to right on those. When adding and subtracting are together, you go left to right. So let's go ahead and apply that. Here in this first expression, we have subtraction and adding. So we do have them together, so just go left to right in their order. So what you would do is first do 6 minus 4, which is 2. And now it becomes 2 plus 8, which is 10. This next example, we have division, subtraction, and multiplication. When multiplication and our division are together, go left to right. So because the division comes first, I'm going to do 10 divided by 2, which is going to be 5. Then we'll do minus 3 times 4 still. I'm going to come back and do this multiplication next. And I can just keep it as 5 minus, and then just do 3 times 4, which is 12. So this would be 5 minus 12. And then 5 minus 12 is -7. Now this next one here, we now have parentheses, so we have to do the parentheses first. So -6 plus 2 is going to be -4. So it's 4 minus, in parentheses, it's -4 squared. Now we do have exponents next, which is -4 squared. -4 squared means -4 times -4. This right here becomes +16. So it's 4 minus the +16. Now we're just left with subtraction, and when you subtract 4 minus 16, you get -12. 1.2c, evaluate expressions and use order of operations to simplify. So the only difference is we now have to substitute a value in for x and then simplify using PEMDAS. So here x is 3, so let's just take x of 3, this value, and substitute it in for there. So 3 plus 5 is the question. The answer is 8. The next one here, what they want us to do is put -1 in for x. Be careful, there's 2 places. So it's 3 times -1. And then in other parentheses, it's going to be a -1 minus the 14. This one's a little bit trickier. We do want to do these parentheses first. -1 minus 14 is -15. Is that value. And the -1 and the 3 are all still here. Now, this is actually all multiplication. This is not subtraction here. If it were subtraction, you'd see a negative sign in between these parentheses, and it's not. So I'm going to do 3 times -1, which is -3. And then I'm going to keep the -15 there. So -3 times -15 is going to get us a +45. Now this one here, we're going to put a -7 in for x. So let's go ahead, put the -7 in the x. So in parentheses, it would be -7 squared minus 25. -7 squared means -7 times -7, which is +49. So this is 49 minus 25. If you do that, what you're going to get is 24. 1.3b, identify coefficients, constants, and like terms. Let's actually do the like terms first. So our like terms are 9x squared and 3x squared. Those are the like terms. The constants on here, the constant means it is just only a number. There can't be any variables. Well, if you look at this, that has a variable, a variable, a variable, and a variable. The constants on here, there are none. So the constant here is 0. And then the coefficients are the numbers in front of the variables. So here we have the variable of x squared, and x. What numbers are in front of them? There is a number there, here, and here. So what I would say for this one, let's actually work backwards. The coefficient is the number in front of it, and it does include the sign in front of it. So this is actually the coefficient of negative 11. The coefficient here is 3, and this one here is 9. And then the coefficient for this first term, there actually is a number in front of here. You just don't see it. There's actually the number 1. So the coefficient here is a 1. 1.3c, simplify expressions by combining like terms. Again, like terms mean the same variable and the same exponent. So right here we do have the same variable to the first power, and it's to the first power. So all we have to do is do negative 5 plus 7. Negative 5 plus 7 is 2, and then we put an x with it. This one here is just what we saw from above. Now we do have the like terms. We have 2x squareds, and then we also have the single x's. So if we combine them together, let's combine the x squareds first. We have 9 plus 3. 9 plus 3 is 12, and that means there's 12x squareds. Here we have an x, 1x, and a negative 11. So it's 1 minus 11. 1 minus 11 is negative 10, and we put the x there. And that's our final answer. This next one here, before we can combine like terms, we have to do our distribution. So let's go ahead and distribute the 2 to both of these. So it's going to be 15 plus 2 times 3 is 6x. 2 times a negative 7 is negative 14. Now we do have one set of like terms. They're the constants. This is a constant because there's no variable. So 15 minus 14 actually is plus 1. And don't forget there we have the 6x. So 6x plus 1 is our answer. Learning Objective 1.4a is solve one-step equations. Here we have 3 different problems. Let's do this one first. All you need to remember to solve equations is whenever you cross over the equal sign, to move a number, always do the inverse of the original operation. So if you have subtraction, the inverse of that is adding. So to get z by itself, I want to move the minus 5 by adding 5 to both sides. And when you do that, you're going to get z is equal to 19. For the second one, it's 5 times y equals 20. To get y by itself, if it's being times by 5, to back that out, you divide by 5, which is called its inverse. So divide by 5. 20 divided by 5 is going to be 4, so y is 4. For this one here, you have 1/4 times x equals 12. Now, when you have a fraction being multiplied by a variable, there's a really nice trick to move it. One thing you could do is you could come in and instead of doing 1/4 times x, you could divide this one side by 1/4 and divide this by 1/4. A nicer way, though, is to actually multiply by the reciprocal of the fraction. The reciprocal of 1 over 4 is just 4 over 1. So if you multiply both sides by 4 over 1, what happens is 4 divided by 4 is 1, 1 divided by 1 is 1, so the x clears out. So all you end up doing is 12 divided by 4, which is going to be 48. So the answer here, x is going to be equal to 48. Again, I said you also could have divided by 1/4. I just caution you because when you do that, what you get is you would see 12 divided by 1/4. You do have to simplify this fraction. To simplify this, it does become 48, so you just have to be really careful with that one. 1.4b is going to have us solve multi-step equations. Again, our goal is just to get x by itself. So if we look at this first problem right here, here's our x. To get x by itself, we have to move the minus 7 and we have to move the 18. always work your way toward the x. So the 18 is the furthest out. This is a positive 18, so to move that one, what you're going to want to do is subtract 18 from both sides. When you do that, you're going to be left with a negative 7x equals negative 14. Now this is negative 7 times x. To get rid of times, all you're going to do is divide. So divide both sides by negative 7. Negative 14 divided by negative 7 is a positive 2. Now for the second one here, there's a couple things you could do. It's a negative times the x plus 2 equals to negative 8. One thing you might want to do is you could distribute this negative sign all the way through. So if we do that, we'll rewrite the problem, and what we're going to end up getting is going to be a negative x minus 2 equals negative 8. Now to get x by itself, we have to move the negative and the minus 2. Again, go furthest out and work your way toward the x. So let's get rid of the minus 2. To back out minus 2, you add 2. Then you're going to have a negative x here equals negative 6. Now this is just negative 1 is what that really is, times x. To get rid of a negative 1 that's being multiplied, you just divide both sides by negative 1. This is going to give us x is a positive 6. 1.4c is going to have us solve equations with variables on both sides. So here we have 4 different problems, and let's start with this first one. When there's variables on both sides, here we have a 2x and a 4x. We need to get the x's on one side and the numbers on the other. So you can really start this problem 4 different ways. I can either move the 2x over here, the 4x over here, the 3 over here, or the negative 15 over here. They are all correct. I personally am going to decide to move the 4x over here. So to cross over this equal sign here, to move a positive 4x, I'm going to subtract 4x from both sides. So I'm going to line those up, and then I'm going to have a negative 2x plus 3 equals negative 15. Now because I chose to have the x on the left side of the equal sign, this 3 has to move over here. So to move a plus 3, I'm going to come in and just do minus 3. It's going to leave us with negative 2x equals negative 18. Now negative 2 times the x means to get rid of times, I divide by, so I'm going to divide by negative 2 on both sides. Negative 18 divided by negative 2 is going to be positive 9. Now this problem over here, we have an x here and here. I'm going to go ahead and move the 5x over to the left side. It's a positive 5x, so let's go ahead and subtract 5x and line those up. Now when I add down, I have 2x minus 3 equals 17. Again, because my x is on the left-hand side of the equals 2, the minus 3 must move over here. To cross over the equals 2, do the opposite, or the inverse of minus 3, which is going to be plus 3. So when we do that, we're going to get 2x equals 20. 2 times x, to get rid of times, again I'm going to divide. So divide both sides by 2. 20 divided by 2 is going to be 10. This problem here, it looks like we first have to deal with the parentheses or do the distribution. So let's distribute the 6 to both pieces here. So 6 times x is going to be 6x. A 6 times a negative 6 is going to be negative 36 equals a negative 2x minus 4. Now again, I have a 6x here and a minus 2x. I'm going to bring the minus 2x over. To back out a minus 2x, I'm going to add 2x to both sides. And then that's going to give us an 8x over here. Minus 36 equals a negative 4. Don't forget the number here does own the sign in front of it, so don't miss the negative 4. To move a minus 36, I'm going to add 36 to both sides. When you do that, you're going to be left with 8x equals a positive 32. To back out 8 times x, you're going to divide by 8. And when you do that, you're going to get that x is equal to 4. This fourth problem here, let's again start by distributing the 3 through first. And when we do that, we're going to get a 3x minus 3 equals x plus 7. Now, again, I'm just going to choose to move this x over here, but I could move the 3x over here. So to move a positive x, I'm going to subtract x. And that's going to leave me with a 2x minus 3 equals 7. To move minus 3, I'm going to add 3. And that's going to leave me with 2x equals 10. 2 times x, to get rid of the multiplication, I'm just going to come on in and divide. Therefore, x is going to be equal to 5. Learning Objective 1.5a wants us to solve an equation for a defined variable. They want us to solve each equation here for the letter y. So what I'm going to do for this first one is to isolate, look at the y and get that by itself. So to get y by itself right there, I have to get rid of the 2 and I have to get rid of the 3x. Again, I'm going to work my way toward the variable. Leave the 2 till last. To move a positive 3x, I'm going to just go the inverse or backwards. I'm going to minus 3x from both sides. When I do that, I get 2y equals 6 minus 3x. Now careful, you can't combine these together. That's a constant number. That's a variable with an x. You just leave them. To get y by itself, it's 2 times y. To get rid of times, I'm going to divide. I'm going to divide everything by the 2. So when I do that, I get y equals, be careful, 6 divided by 2 is 3. And then minus 3x over 2. And that is our answer. Now for this one here, to get y by itself, let's just isolate the y real quickly. When we look at that, the y is right here. So what I have to do is to get rid of the minus 5 and the 3x. Again, work my way toward the y. The 3x is furthest out, so move that first. To move a positive 3x, I'm going to minus 3x from both sides. It's going to leave us with a minus 5y equals 15 minus 3x. Again, be cautious. This 5 owns that negative sign, so don't lose it. This is negative 5 times y. To get rid of multiplication or times, I divide. I'm going to divide every little piece of this equation by the negative 5. When we do that, we're going to now get y equals, be careful and simplify, 15 divided by negative 5. In your calculator, if you check, it's negative 3. Here I have a negative divided by a negative. A negative divided by a negative actually becomes a positive, and then it's going to be the 3x over 5. So the final answer is this. 1.5b wants us to solve a formula for a defined variable. So here they have the distance formula, which is d equals r times t. They want us to solve for r. This is not a hard problem. Don't overcomplicate it. Here it is. They want us to get r by itself. That's the letter. Notice what's happening. It says r times t. To move anything that says times, all you have to do is reverse it out and divide. So we have to move the t, so I divide both sides by t. So what I get is d over t equals r. And normally we write the answer, which is r equals d over t. Do you know that this equation here is the same as that? This one right here is just more of a typical format where the answer is written first, where it's r equals, and then the final answer. 1.6a and b go together. Write an algebraic model from a story problem and solve a story problem. So here we have a taxi driver charges $3.50 plus $1.75 per mile. We ride the taxi and it costs us $21. Write and solve an algebraic model to find the length of your ride in miles. So what we know is that it actually costs something. So I'm just going to write somewhat of a verbal model first. So we know that the cost of the cab is the $3.50 when we first get in, plus they're going to charge us $1.75 per every mile. We'll make this more of an algebraic, so I'm going to say cost equals 3.5 plus 1.75 m. So that would be our algebraic model, and we have this part done, which is there. Now they want us to come in and say, wait a second, total cost is $21, so let's make that $21. And when you do that, the next question is, how many miles did we drive? Well, if you look at the equation, if we solve for m, we'll figure it out. To get m by itself, we have to move the 1.75 and the 350. This is furthest out. So let's start by subtracting 350 from both sides. When you do that, you're going to get 21 minus 350, which is going to give us 1750. And that equals 1.75 times m. Now, to get m by itself, all we have to do is it's 1.75 times m. To clear out the times, we're going to divide everything by 1.75. And when you do that, you're going to get that m equals 10. Now, be careful to answer the question. It's 10 miles. So let's add a label to that and circle our answer. The next one here, tulip bulbs cost $7 per pack. Crocus bulbs cost $4 per pack. You buy n packs of each type of flower bulb, and you pay $44. How many packs do you buy of each? Now notice here we buy n packs of each type, so we buy the same number of packs of each type. So let's just write this equation out. So we're going to do $7 times the tulip cost, the tulip amount, plus $4 times how many crocuses that we buy, and that's going to be our total cost. So if I simplify this, do we know how many packs of tulips and how many packs of crocuses we bought? Yeah, it's n. So let's replace that word with n in both of these spots. So we're going to get 7n plus 4n. And what we know is it equals the total cost, which was $44. So this is our algebraic equation. To go ahead and solve this, all we have to do is add together our like terms on this side. Now be careful when you add these together. Notice they're on the same side of the equal sign. You don't have to add or subtract or do the opposite. You just crunch these together. So 7n plus 4n is 11n equals 44. To get n by itself, 11 times n, you're going to divide. And when you're going to do that, n equals 4. So again, answer the question. It's going to be 4 packs of each. And circle our answer.